In this video lesson, we are looking at solving system of inequalities. You have already learned to graph inequalities and to solve an inequality, but this lesson is specifically about solving a system where you have two inequalities, all right? So we're going to take a look at this little diagram, which is the progression of how we determine the solution to an inequality. This first graph here in slope-intercept form is y greater than x minus 1. So you see the graph. Of course, it's a dashed line because it's only greater than. The y-intercept is -1 and the slope is 1, okay? And it's greater than, so everything is shaded above that dashed line. The second equation in slope-intercept form is y greater than -x plus 3. So the y-intercept is at +3. The slope is -1, so down 1 over 1. You have another dashed line because it's only greater than. And again, because it's greater, you have everything shaded above. Well, when you put these two together, you see that the red shaded region and the blue shaded region overlap and create this, maybe we could call it purple shaded region here. That is where your solutions or solution to the inequality is found. Any point inside of the shaded region would be considered a solution. So we could pick this point right here, and that's at 2, +3. So we could say that one of the solutions would be 2, +3. Now, when you have an overlapping shaded area like that, you're actually going to have an infinite number of answers because those graphs continue going on infinitely. But let's go ahead and just take a look at this next diagram real quick. Again, when you have your graphs that overlap, your solution is in the region that is double shaded, okay? We could say that's infinitely many solutions because these graphs are going to continue on forever, okay? But now if you have a graph where your lines are parallel, but the shaded regions don't ever overlap, then there's no solution, okay? And then the other two options is where your equation or your inequality graph is the same, okay? Except for one is shaded greater than and the other one is maybe shaded less than. And the shadings don't ever overlap, but they share that line. And if that is a solid line, because the equal to sign is included, then the solutions are any of the points that are on that line, okay? Now, if your inequalities, your system, again, they do not overlap, okay, and you have the dotted line, then there's actually no solution, okay, because nothing is included on the dotted line, and then the shade does not overlap, so there would be actually no solution here. All right, so here's your infinite many solution side and then your no solution examples. All right, let's take a look at this one example here. This says that you like to see how many baseball and soccer games you can attend this spring. Traveling time for baseball games is 2 hours and soccer games is 1 hour. You would like to spend no more than 15 hours traveling to the games. In total, you would like to attend at least 8 games. All right, so we have some questions here. We want to write the system of the linear inequalities. And then we want to consider some questions here, and then we can graph it, okay? Now, I'm going to go to the next slide just to work on, first of all, writing our system of inequalities, all right? Now, the first thing we always want to do is to label our variables, okay? Our variables are the soccer games and the baseball games, okay? So I'm going to call X our baseball games and call Y the soccer games so that I can consider our inequalities. Now, it also tells us that the time to travel to the baseball games is 2 hours, okay, which would be 2x. And then our soccer game is just 1 hour, so that would be 1y. We could just write y, okay? Now, it says that you would like to spend no more than 15 hours traveling. No more than, okay? That's a key phrase there, no more than 15 hours traveling. Well, here's what that equation looks like. That would be 2x plus y less than or equal to 15 because that's 2 hours for every soccer game, to travel to a soccer game, and 1 hour for every baseball game, and no more than, so less than or equal to 15, okay? Now, it also says that in total, you would like to attend at least 8 games. So when we add up just the baseball games and the soccer games, we want it to be at least 8 games. Let me go ahead and highlight that, at least 8 games. That's what makes this an inequality, all right? So that inequality looks like this: x plus y greater than or equal to 8, all right? Now, for graphing purposes, I'm going to convert these to y-intercept form. So let me go ahead and separate them so that I can work on them. So now that you can see that when the equations have been converted to y equals mx plus b, or slope-intercept form, we have y greater than or equal to negative x plus 8. That's one inequality. And then we have y less than or equal to negative 2x plus 15, the other inequality. So we have our system of inequalities. So now let's take a look at what it looks like graphed. All right, so you can see here that when we've graphed the inequality, y greater than or equal to negative x plus 8, we have this graph right here, okay? But then we need to shade everything greater than or equal to that line. And when we do that, we're going to shade everything above. So we could actually just kind of do like this. We're shading everything above it, okay? And then our other inequality is y less than or equal to negative 2x plus 5. You can see in blue here that I have graphed it. But then we need to shade everything that is less than or equal to that. So let's go ahead and shade everything below that. And then you can see that our answers are inside this area here. That would be where we would find our double shaded region. So now let's just take a look at this last question here. It says, is it possible to attend 6 baseball games and 4 soccer games? Now remember, if it is possible, it is in our double shaded region here. All of these ordered pairs are the solutions. So is it possible to attend 6 baseball games? So we'll go out to 6, 1, 2, 3, 4, 5, 6, and 4 baseball games, 1, 2, 3, 4. So it actually looks like it is not possible to attend 6 baseball games and 4 soccer games. Now, what would be possible? Let's consider some solutions that are possible. So let's say we attended 2 baseball games, then we could attend, let's see, 1, 2, 3, 4, 5, 6, 7, 8 soccer games. So 2-8 would be one of our solutions in this set of ordered pairs. 2-8. So again, anything inside of this region is our solutions, okay? And that's how you solve a system of linear inequalities.